Hey everybody, welcome back. So today we're going to do a quick introduction to periodic functions. Now, I want you to think about Math 130 up to this point. What have we studied? We studied linear functions, quadratic functions, exponentials, logarithms, rational functions, polynomials, and more recently, piecewise defined functions. Now, all these functions are nice and all, but they are missing a certain property that we actually see in real life, and that property is this periodicity, or this repeatingness, because there are certain things in life that repeat. I'm going to give you some examples today. I'll show you some videos to give you a visualization, but sort of think about the sun in the sky, right? The sun rises and then sets, and then it rises the next day and then sets, and then rises and then sets. So there's this repeatingness phenomenon that's going on. And the functions we've talked about up to this point don't have that. But that's where periodic functions come in. Now, what are periodic functions? So this is the pinkies up definition. Periodic functions are functions that repeat a set of values every p units, okay? And p is what we call the period. Now, what this is saying is that this function is going to repeat the same pattern over and over again, and it completes a pattern in p units, or again, what we call the period, okay? So again, periodic functions are these functions that have this built-in repeatingness that we see in real life sometimes. Now, our first example, which should look very similar to the Ferris wheel example in your book, consider a 31-inch tire and a point Q. Okay, and if you look at the picture here in my super awesome tire drawing, Q, we're just going to start it at the bottom of the tire there. So consider a 31-inch tire and a point Q on the circumference of the tire. The tire spins constantly so that it makes one revolution every second. Okay. So assume that at time t equal to 0, okay, the height of the point Q is 0 inches. So again, this is just saying that Q, like in our picture here, is at the bottom, okay, at least when it starts. The height of Q is actually a periodic function, okay, and that's what we're going to investigate here. So what we know about this tire is that every second it makes one revolution, right? So that means that every quarter second, okay, so at like 0.25 seconds, it's halfway up the circle, which means that it's at height. Let's see, what's half of 31 inches? That's 15.5 inches. Then at half a second, it's up here at the top. Oh, wait, which way is this spinning? I'm going the right way. Okay. Just making sure, I'm not going crazy. And then at 0.75 seconds, it's right here. Okay, which again is back at, and I forgot to put the height here at 0.5 seconds. The height is, well, what's the height of this tire? It's 31 inches. And then at 0.75, it's back down to about halfway. And then at 1 second, it's completed one revolution. So it's right here, okay? So notice I have some tables here. Let's actually write this down. So at time 0, the height is 0. Okay, at time 0.25, we're at 15.5 inches. At 0.5, we're at 31 inches. At 0.75, we're at 15.5 again. Okay, and then at 1 second, notice we're going to start repeating the value. So once 1 second has gone up, the point has gone all the way around the circle and it's back where it started again. Okay, and then if we go another quarter second out, so 1.25 seconds, it's going to be back at 15.5. And then at 1.50, we're back up to 31, 1.75. We're at 15.5 again. So what I want you to notice is that as we're traversing the circle in this case, or the tire, notice that it's repeating the same values over and over again. If you imagine this wheel that just keeps on spinning, the point Q is going to repeat the same values over and over again. It's going to repeat the same heights over and over and over again. So the height of this point Q on this tire here is a periodic function. Okay, again, it's repeating the same values over and over again. Now let's see some other examples that you may not be familiar with. So our first example is a heart rate monitor. And this, again, this measures a person's heartbeats, basically. Okay, and let's assume that this person is at rest, but notice that it's essentially repeating the same pattern over and over and over again. And if you look at this graph here, we haven't studied anything like this that does this kind of repeating phenomenonness. Okay? So here's something in real life that we don't have the functions necessary to construct this image. Kind of going back to my original example, here's the sun rising and setting over Bristol. Okay, so notice how it rises. What's it going to do? It's going to go up, and then eventually, I'm going to go a little bit forward. It goes down, and then imagine, what does it do the next day? It's going to do the same thing. It's going to rise up and then come back down. Okay, again, something that happens in real life that we don't at this point have ways to model this. And another example, since we're at the bay, we have the ocean right next to us. If you think about the height of a buoy over time, okay, what's happening to the height of buoy? It's bobbing up and down, right? Now, this is not repeating the same pattern necessarily, because there's a little bit more chaos with waves and things like that. But again, this is still sort of a periodic phenomenon. What's the buoy doing? It's going up and down. It goes up and then down. And then once a wave hits it, it goes up and then it goes down. Okay. So all these types of real life things that we like to model can be modeled using periodic functions. And that's what we're going to study. And that's where trig comes about, which we'll get into very, very soon.